Let's look at the answers to these questions that you've been in the other day then. So number one there, we've got a train there called the Mallard, which is the fastest British locomotive, travelled at a velocity of 200 kilometres an hour. And question A says, how long would it take to travel a distance of 400 kilometres? So the displacement there is 400 kilometres. And how long means how long in time. So what's the time there? And don't forget what we're doing here is using V equals S divided by T, or in a triangle form, we're using it like that. So if we're trying to find time here, you would cover the time up there, and that would mean time is displacement over velocity. So that's the formula you're going to use, T equals S over V, and this is in kilometres an hour and kilometres, so they're okay as they are. So we're going to go for a distance of 400 kilometres divided by 200 kilometres an hour, so you'll get 2, and that'll be in hours, because that's what your time is set in at the moment. When you're doing part B there, part B off your question sheet is how far would the Mallard travel in 1 minute? So how far in a minute? So this time they've given you a time of 1 minute, and you're trying to work out how far, which is a displacement or a distance travelled, and that's what they want you to try and find out. And we've got a velocity still of 200 kilometres per hour. So because we're trying to find S here, this one, we're going to cover up the S this time. And if you're covering the S up, it'll be V times T is the answer. So S is equal to V times T. So we've got something in kilometres per hour, but you've got a time in minutes. Now you can't have the velocity in kilometres per hour and the time in minutes needs to go into hours. So there are 60 minutes in an hour, so it's 1/60th of an hour that you've got there. So you need to times that by 1 divided by 60. And if you do that, you get 200 over 60, and you'll get 6 threes are adding 3.33. This is in kilometres an hour, so it'll be kilometres. That's how far the Mallard should travel in that 1 minute there. Okay, you're looking at part C there. Convert 200 kilometres an hour into metres per second, and we said there was a straight conversion that you could use for that, where you would just divide by 3.6 to convert into metres per second. So if we divide it by 3.6, we'll get into metres per second. So 200 divided by 3.6, and you get 55.6 metres per second. So that's how you're doing the first lot. If we look at the next ones here, question 2. Question 2, light travels at 3 by 10 to the 8 metres per second, so that's its velocity. And you can put that into a calculator by using the EXP button there. So instead of writing times 10 to the power of 8, the EXP button will do all those buttons for you. So you would do 3 EXP 8, and that would put it in for you in one go. Okay, that's called scientific notation or standard form. So light's travelling to the Earth there, and we want to know how far would it take to reach the moon, light from the Earth to the moon. So that would be a distance they've told you to the moon of 385,000 kilometres. So that's what they've given you so far. Whereas this is in metres per second, by the way. So we're trying to find time here because it says how long will it take for the light to reach the moon, or reach the moon from the Earth. So looking at that, we're trying to find time. Again, using your triangle, we're doing T equals S over V. And the displacement here is going to be in kilometres, and the the speed of velocity is in metres per second. So that's no good to us really. We're getting both into metres and metres per second. So this one here, we would need to times that by 1,000 to convert the kilometres to metres. So we add 3 zeros in the end. You're going to divide by 3 by 10 to the 8. And if you do that calculation, you get about 1.28 seconds. So as I said, you can just use that as an exponent button there. Some buttons are actually written as times by 10 to the x, actually written like that. When you press the button, it shows you the buttons that they're doing by pressing that one button. Okay, so that's question 2. Question 3. You've got question 3 there. Question 3 is Mars is 80 million kilometres from the Earth at its closest point. If light travels at this speed, how much time will elapse before the space scientist knows that the command has been received by a spacecraft on the surface of Mars? So here we've got a distance to Mars of 80 million kilometres. So that's 80 million, that's 80 million is 8 with 6 zeros, and that's in kilometres. The speed of light for a signal is still 3 by 10 to the 8. in metres per second, and they want to know how long will it take to receive it back. So using the same formula of t equals SA over v there, okay, this time we've got a distance of 80 million now. So if we look at this, there's actually going to be 7 zeros and another 3 zeros, so that's 10 zeros. So being smart about it, we've got 8 by 10 to the 10 for 10 zeros in metres, divided by 3 by 10 to the 8 for metres per second. And that means we'll get our answer in seconds there because everything's in metres and metres per second. So looking at that there, you'll get about 266.6 or 7 seconds. Now that's the time it takes to just get there. But the signal's got to be received back, so we need to double that to get the total time, which is actually a bit of a trick to the question there. So you would actually do 2 times by 266.6 roughly. And you get 533 roughly in seconds there. So if you divide by the 60, get it into minutes, it's about 8.5 minutes, I think it is. So it takes a while for the signal to get there and return if you're sending messages to Mars. Question 4. If we look at these fairly quickly then, you're looking at going from 1 kilometre to metres, so you times by 1,000. So 1 kilometre would be 1,000 metres, just times it by 1,000. Part B, we're looking at doing 5,200 metres into kilometres. So metres to kilometres you need to divide by 1,000, which gives you 5.2 kilometres. Part C, we're doing 530 centimetres into metres. So centimetres to metres you need to divide by 100 because there's 100 centimetres in a metre. So that'll be 5.30 metres. Part D, 24.5 kilometres into centimetres. You need to divide by 1,000 to get it into metres and divide by another 100 to get it into centimetres. So we're going to move it 5 places off to the right. So you get 2, 4, 5, and another 4 zeros on the end. So you've moved it 5 places there to get that into centimetres. Okay. E, 5 minutes to seconds. So 5 minutes you'd have to times by 60 to get it to seconds because there's 60 seconds in a minute. That gives you 300 seconds. F, we've got 10 hours 30 minutes into seconds. So again, they're going to have to times that by 60. So 10 hours 30 minutes is actually 10.5 hours. Times by 60 to get it into minutes. And to get it into times by 60 to get it into minutes, and times by another 60 to get it into seconds to get them there. Okay. So 10.5 times by 3,600. And you get 37,800 there. Look at that. Yes, 37,800 seconds, so it's a lot. And we can keep going there. For G, we'll go down a bit. We go down to G here. G is 5 milliseconds to seconds, so if you look that up on your multiplier, it's 5 by 10 to the minus 3, or 0.005 would also be the answer. Either's acceptable there. For H, so H we're converting 10 metres per second to metres per hour. So if you've got 10 metres per second and you're trying to get it into hours, 10 metres in a second, how far would it travel in an hour? Well, in an hour there's actually 60 minutes in an hour and then another 60 seconds in a minute. So we would need to really times that by 3,600 to work out how far it would go in 3,600 seconds to get doing it per hour. So that would be 36,000 metres per hour. Okay, it'll go a long way in an hour. At 10 metres a second, it's going to go a long way in an hour. All right, if we look at I. All right, for I, we're going from 10 metres a second to kilometres per second, so 10 metres per second into kilometres per second. So if it's done 10 metres in a second, to do 10 kilometres, if it's done 10 metres in a second, it's not going to do very many kilometres in a second. It's a very small fraction. In fact, it's 1,000th of that. So you have to do 10 divided by 1,000 to work out how many kilometres per second it's going at. So 10 divided by 1,000 is 100th, or 0.01 kilometres per second. So it's going pretty slow in kilometres per second. In J, and these are rather unusual conversions, some of these that we wouldn't normally do. In J, 10 metres a second to kilometres per hour. Well, 10 metres a second used times by 3.6 to get into kilometres per hour. That's the rule. 36 kilometres per hour. And for k, we've got 50 metres a second to kilometres an hour. That's the same thing again. You're just going to go 50 times by 3.6. It's going to be 180 kilometres per hour. Okay, 50 times by 3.6 is 180 kilometres per hour. And L, we've got 800 kilometres an hour back to metres per second, so we're going to divide by 3.6 to go back the other way. Is 222.2 metres per second. Okay, or metres seconds to the minus 1. Right, last question. Question 5. If it takes 8.33 minutes for the light from the sun to reach the Earth, how far is the sun from the Earth if light travels at this speed? So we're working out how far it is, which means we're doing v times by t. And we're told it's going at 3 by 10 to the 8 for the light. And we're told that it's 8.33 minutes. Now this is in metres per second, so we must have this in going changing from minutes to seconds as well. So we need to times that by 60 to convert from minutes to seconds, because it's 60 seconds in a minute. If you multiply those together, you'll get how far away it is in metres. So that's a long way away in metres. And the last question there, given that given that a light year is the distance travelled by light in a year, compute this distance in kilometres. So a light year is the distance travelled by light in 1 year. So we know that light's travelling at 3 by 10 to the 8 metres per second. And the time for 1 year then is, 1 year would be 365 days, or 365 and a quarter days to be exact, 0.25. And each day's got 24 hours, and each of those hours would have 3,600 seconds in them, 60 minutes and 60 seconds. So you would have to multiply all those together to work out how far a light year is in metres. So it's 3.9447. (10 to the power of 14). So that's a long way.